Okay, today we are going to talk about absolute value. What do you guys know about absolute value?
Positive.
It's always positive?
No.
I would say yes and no. It's not always positive. And I'll show you why here in just a moment. Absolute value, remember, it measures the distance. It measures the distance from 0. So when you're talking about how far away is something on a number line from 0, we can talk about its absolute value. And we know things like this, like if I have the absolute value of 7, what that is asking is, it's not saying turn it into a positive number, it's saying how far away from 0 on the number line is 7. And what's your response?
7.
It's 7 units away. What's the absolute value of negative 20?
20.
It's 20 units away from 0, so we just say 20, right? So this is stuff that you guys know, and we should be happy with that. What's the absolute value of 0? It's 0, right? Is 0 positive or negative? It's neither positive nor negative. So going back to what you said, the absolute value is not always a positive number. Forget it. What if I have the absolute value of x? I disagree with you. The absolute value of x is not x, and in fact, it is a piecewise defined function. It's negative x if your x value is less than 0, and it's a positive normal x if your x value is greater than or equal to 0. Think about the examples that we have here on the left side. If I plug in 7 into the absolute value, isn't 7 greater than or equal to 0? Yes, therefore the absolute value just returns that number 7. But when I plug in negative 20 is less than 0. So according to the definition of the absolute value, it doesn't return that same value that you plugged in, it returns the negative of that. So what's the negative of negative 20? Positive 20. That's how the absolute value works. And that's why when we graphed this guy a long time ago, negative x, if we look at this as a line, it is a line that does this. If we were to continue past 0, it would keep going on like that. But as a piecewise defined function, it would stop right here at the origin. Well, the other part is just y equals x, and y equals x is this guy. And it would have continued on the left side like this. Now it does equal 0, so it fills in that open circle from before. So here is that absolute value shape that you guys already knew. But what's going on here is that you see that it's really a piecewise defined function. What do you guys think? I know it's mind equals blown. Just if you have questions, you can always go back and watch these videos. I would tell you what the URL is, but if you're watching this video right now, you already know it. And thank you for watching. I appreciate my loyal subscribers. Make sure that you check your virtual mailbox for some kind of goodie bag for me.
I already got mine.
You already got yours, great. I guess my secretary sent those out a little bit earlier this year than I had anticipated. So, here's absolute value, but we've got to talk about the fun stuff. We have to talk about absolute value equations. And the thing is, you already know what's going on here, and you can figure this out because you guys are smart kids, right? Or smart adults. Now, some of you are adults. If you're not a teenager anymore, if you're still a teenager, enjoy it. Live it up legally and responsibly live it up. So if I were to ask you this, if I were to ask you to solve this equation, the absolute value of x is equal to 6. When I ask you to solve, that means I'm trying to find every replacement that would make this equation true. What could you replace x with so that this equation is true?
6.
Right, you know that if you were to let x equal 6, or also, if x were equal to negative 6, then we'd be in good shape, right? So we have two solutions here. Isn't this exciting? I know, I just can't even contain myself. It's a good thing I'm sitting down for this. Well, this is really the simplest guy that we could even talk about. But I want you to consider this, the next guy. What if I say the absolute value of x, I want you to solve the absolute value of x is equal to negative 3. Why are you looking at me like I wrote something wrong? What do you want to say about it?
Nothing.
No, what do you mean nothing? You don't want to say anything about it?
I was waiting for you to continue.
Tell me your thoughts about this. Tell me all your thoughts about the absolute value of x equaling negative 3. Yes?
Wouldn't you make the x a negative, so it's negative 3 is less than 0, or no?
But you have to look at your input value. See, negative 3 is not your input. Negative 3 is the output. How can I take the absolute value of a number and get negative 3? Do I have a negative outside the absolute value? Okay, so once again, how can I get a negative response, a negative result from the absolute value? I can't just throw in a negative 1. What I have what I have. I am what I am. This is a Popeye equation, all right? You can't just put extra things in here. It is what it is. Look at all these guys we had up here for the absolute value. The absolute value is equal to positive 7, positive 20. It equals 0. When does the absolute value equal a negative number? Oh, like the tree said to the lumberjack, you're stumped? Let's come back up here to this guy that's in green. You know that you can graph these guys, right? If I were to graph the absolute value of x, if we were to pretend that this is, say, y1 in our calculators, and we were to say that 6 is our y2. So if I were to graph y1, the absolute value of x is this guy right here. Okay, so here's my absolute value of x. How do you graph y equals 6? But it's just isn't it just a horizontal line? So here's 6. How many intersection points do these two graphs have? They have 2 intersection points, and they happen to occur right here when x is 6, and also right here when x is negative 6. That's how I have my 2 solutions. Well, look at this guy right here. If I were to graph him, here's my absolute value of x function. How do you graph y equals negative 3? You come down here to negative 3, right? And you draw your horizontal line. How many points of intersection do I have between the absolute value and this horizontal line? None. Because when does the absolute value equal a negative? Never. So what would we say about the solution here? There is no solution. What do you guys think? Amazing? Absolutely amazing. So does this mean that we always have either 2 solutions or no solution? Yes? Well, let me give you another example, because you know this is how I roll. If I say the absolute value of x is equal to 0, what does that mean? When does that happen?
Right up to.
Only at 0, right? So the solution here is x is equal to 0. You can't say x equals 0 and x equals negative 0. Because what's negative 0?
It's a positive or negative.
Right, if you put a negative, if you multiply 0 times negative, it's still 0. So there's only one solution. You can imagine, like up here, if I were to graph y equals 0, it would just be this guy right here. And so it would only intersect at that one point right there, which is the vertex, when x equals 0.